Hello and welcome to Technical Utkranti, and today we'll see the next question, which is finding all majority elements whose frequency is greater than n by 3 times in the array of length n. So this is the 17th question of the arrays that we have done till now, and let's look at the question and the answer. So if this is the input array of length 7 with 4 occurring 2 times and 3 occurring 4 times, we see that the majority element with frequency greater than 7 by 3 is just 3. But over here, where 4 is present 3 times and 3 is present 4 times, both 3 and 4 constitutes the answer because both of these frequencies are greater than 7 by 3. So let's look at the first approach into solving this question. So the first is the very naive approach in which we count the occurrences of each element in the array in a nested loop implementation format, uh, and see if the count for any particular element is greater than n by 3. We include it in the answer. So as you can see, this is the input array, and I've calculated the threshold and the number of majority elements. I've taken the set of all the elements which just have the unique elements of the input array, and I'll just keep the count of each of these elements. And as you can see, I will just iterate over the array again, and if the two elements are same, I'll increment the count. And after having obtained the count of I, I'll see if the count is greater than threshold, then I'll print it. And yeah, ultimately if the number of majority elements is equal to 2, I'll break off. This condition is done just because there cannot be more than 2 elements whose frequency is greater than n by 3 in the array of length n. I hope the implementation is clear. Let's just see what we get as the answer. So over here, there will be 4 and 3 both as the answer. So let's check this out. Yes, and for this input, we should have only 3 as the answer. Yes. Let's move on to discuss the second approach. In this approach, we'll have a hash map in which we'll store all the elements as keys and their frequencies as values of the key. And to begin with, all these values will be initialized to 0. We'll then simply iterate over the array, and uh, for each element that occurs in the array, we'll increment the value of its key in the dictionary. And in this way, we'll be able to store the count of all the elements in O of n time complexity only. But there will be an additional space of O of n required. A space complexity of O of n would be required in this implementation. So let's look at the solution. Here I have a dictionary, a hash map, and I have initialized it with all the elements in the array and the values being 0. Then I again iterate on the array and increment the corresponding key. Okay, and then I will iterate on the dictionary, and if any value is greater than the threshold, I'll print the corresponding key. So let's test it out for this. So over here, I should have both 4 and 3 as the output, and for the above one, I should have just 3 as the output. Yes. Let's dive into the third approach. So the third approach involves sorting the given array, and once sorted, all the same elements will come up together. And when same elements come together, we can just see if the length of those same elements is greater than n by 3, then that particular element constitutes the answer. So what I am trying over here is, I will see that if the current element and the element separated by threshold distance apart, if those two are same, then I will append the element into the answer, right? So let's see. So in this case, the solution would be both 3 and 4, and in the above case, the solution should be just 3. I hope the solution is clear. Here what we are trying to do is we are just sorting the array. Once sorted, I'll iterate over the sorted array, and since the same elements have come up together, then if any element separated by threshold distance apart also has the same element, then both of them should be equal, right? So in that case, I'll include it in the answer, and not to in order to not access the out of bound index, I will just have this particular check implemented, which would just ensure that this does not cross the array length limit. All right. Now let's move on to the last approach, which is the most interesting approach, because using this approach we can get the two most frequently occurring elements in the array, and that too in just O of n time complexity without any additional space required. So in part 16 of the video, we have seen Moore's voting algorithm, and what it did was it just found out the most frequently occurring element. In this particular uh, algorithm, which is the extension of Moore's voting algorithm, uh, we will we will just tweak that particular algorithm to find two most frequently occurring elements, and then we'll check the number of occurrences for those two elements in the array, and if the occurrences is greater than n by 3, then we include them in the answer. We need to do this only for two elements because there cannot be more than two elements with frequency greater than n by 3 for any given array. So let's understand the algorithm. Goes like this. So we iterate on the array, and for each element in the array we see that is it equal to E1. So what are E1, E2? We maintain E1 as one element and its C1 count as the relative frequency. Similarly, E2 is a second element and C2 is its relative frequency. These four things we maintain while we iterate across the array. So for any element we see that is that element equal to E1. If yes, then increment its counter and then go to the next element. If it is not equal to E1, then we check for E2. If that is not also the case, then we check the counts of the corresponding elements, like count of E1 and count of E2. So if any of these counts are 0, we make the element equal to we make E1 equal to the element and increment the counter similarly for the second element. And if all those four conditions are not satisfied, which means that we have found an element which is neither equal to E1 nor E2, and both the frequencies of E1 E2 is greater than 0, then we decrement the frequencies of both these elements by 1, and then again go back to the next element. So let's understand this algorithm with this particular example, 4 3 4 3 1 3 3. So firstly we have 4, and these two conditions will not satisfy. C1 equal to 0 will satisfy because C1 equal to 0. Okay, so we will have E1 equal to 4 and C1 equal to 1. As you can see, E1 equals to 4, C1 equal to 1, and then we go to the second element, which is 3. So for 3, the condition satisfied would be this, and we have E2 equal to 3 and C2 equal to 1, and we go to the next element. So we have this. Now next element is 4. E1, it will match with this condition, hence over here it will go to this particular situation. So C1 will become 2, E1 will become 4, and we go to the next element, which is 3. With this, C2 will go to 2 and E2 will remain 3 because this particular condition will be satisfied. The next element is 1, and since 1 is neither equal to E1 nor E2, and C1 and C2 both are non-zero, so the frequencies of C1, C2 is subtracted by 1, as you can see, and the control goes to the next element, which is 3. 3 is equal to E2, and C2 would get incremented by 1, so it would be, yeah, this particular thing. And then again it is 3, so you can guess it, right? C2 will become 3 now. So the two most frequently occurring elements comes out to be 3 and 4, and that you can verify with your bare eyes also, that that is the answer. Now what needs to be done is we need to count the number of times 3 has occurred, or even has occurred in array, which is 2. So 2 is not greater than 7 by 3, and we'll see the number of times E2 has occurred, which is 4, and 4 is greater than 7 by 3. So I mean 3 is greater than 7 by 3. So E2 constitutes the answer. Let's look at the Python implementation of it. So this particular thing is exactly the same as what I've told you inside the presentation. And then once I obtained even E2, I'll just calculate their counts, and if they are greater than threshold, we include them in the answer and print the list of answers. So in this case, I should just get 3 as the answer, and in the second case I should get both 4 and 3 as the answer. Yeah, so that's it. I hope you liked the video. If you do like, do give the thumbs up and subscribe to my channel. And yeah, thank you. Bye bye.